Hello! This will be a demonstration of Proposition 1 from Book 9 of Euclid's Elements, which says that the product of two similar plane numbers is a square number. We're of course given two similar plane numbers, A and B. We're also given their product, C. So A times B makes C. What we want to prove about this number C is that it is a square number. We're going to begin by taking the square on A, call that D. So A times A, or A squared, makes the number D. Now what we have here is that A has been multiplied by two numbers to make two other numbers. A times A makes D, and A times B makes C, the former of which we get from our first step, and the latter of which we get from our given. So we can say by Proposition 717 that the two numbers multiplied have the same ratio as the products, so that A is to B just as D is to C. But we know A and B are two similar plane numbers. We were given that. And so we know from Proposition 818 that there is one mean proportional that falls between two similar plane numbers. So that because A and B are similar plane numbers, one mean proportional falls between them. But we also know from Proposition 8.8 that if four numbers are proportional, then whatever number of mean proportionals falls between one of those ratios will also fall, that same number of mean proportionals will fall between the other ratio. So that because A is to B just as D is to C, we prove that in our second step, and there's one mean proportional between A and B, there's also one mean proportional between D and C. But what this means is we have three numbers that are continually proportional. We have D, the mean proportional between D and C itself. And we know when three numbers are continually proportional, and the first number is a square number, the third number is also a square number. That's Proposition 822. So that because D is to the mean proportional, just as the mean proportional is to C, and the first number D is a square number, the third number C is also a square number, which is what we set out to prove, which means we're done with the proposition, therefore, etc., Q, E, D. What this would look like with particular numbers is that the number 8 is a plane number that is similar to the other plane number 18. I've done this a few times by now. The sides of 8 are 2 and 4, and the sides of 18 are 3 and 6. Those are proportional sides. 2 is to 4 just as 3 is to 6. So the product of 2 and 4 is going to be similar. It is going to be a similar plane number to the product of 3 and 6. The product of 2 and 4 is 8. The product of 3 and 16 is 18. So 8 and 18 are two similar plane numbers. And what follows from this is that the product of 8 and 18 is a square number. The product of 8 and 18 is the number 144. And this is fairly easy to recognize as a square number. This is 12 squared. So we see that the product of two similar plane numbers is in fact a square number, and that this proposition holds. That's all I've got to say about this proposition. I want to remark quickly that I'm quite excited to get into Book 9 demonstrations. I believe I'm actually the first on YouTube to get into this stuff. So that's, of course, exciting. With that said, I'll end the video here and move on to Proposition 9.2.